Our next speaker who is with us live is Markus Ehrenmueller-Jensen. He is the founder of Savory Data and works as a project leader, trainer, and consultant for data engineering, business intelligence, and data science since 1994. He is an educated software engineer, graduated business educator, and professor for databases and project engineering at HTL Leonding, a technical college. And he owns several Microsoft certifications. Markus speaks regularly on international conferences. Examples are the PASS Summit, SQL Bits, SQL Saturdays, and many more. He writes articles for well-known journals. He is the author of Self-Service AI in Power BI Desktop, Self-Service AI in Power BI Desktop, and co-author of Power BI MVP book. Currently, he works on his newest book, Data Modeling in Power BI. In 2013, he co-founded Data Community Austria, formerly known as SQL Pass Austria, and Power BI User Group Austria, and he organizes SQL Saturdays in Austria since 2014. For his technical leadership in the community, he was awarded as a Microsoft Data Platform MVP since the year 2017. Welcome, Markus. Take it away.
Yeah, thank you very much, Steve, for the introduction. And I'm happy to see you again, right? I already saw you yesterday, like 30 hours before, right? So I hope you did catch up some sleep with this event. I'm grateful that you set up something like this. Yeah, and let's talk about advanced data modeling in Power BI. One of my favorite topics. That's why I started writing this book Steve mentioned, right? So advanced data modeling. So if I introduce myself to some people and they ask me, Markus, what do you do for a living, right? Then I tell them I work with models, and sometimes they think I work with beautiful people, which is close to, right? I mean, I work with beautiful data instead. At least when I'm done with the projects, hopefully it's more beautiful than the screenshot here, because like you see, there's that bidirectional filters, and so this is not very beautiful. And we will talk about what makes a model beautiful. It's not so much about if it's really beautiful, it's more about is it useful or not. And there's some rules we will talk about. And in this talk, as it's an advanced topic, I will violate some of the rules. But very important, you need to do your homework before you can do advanced stuff in modeling in Power BI or Excel Power Pivot. You have to do your homework. And your homework is that Power BI and the Vertex engine, so the database engine behind in Power BI and in Excel and in Analysis Services Tabular, for that matter, is the same, right? This is optimized for the star schema. So it's not about a religious thing. If you believe that the star schema is better than one big table or a third normal form, is it, or data vault or whatever, they all have their use cases. And for example, for report builder, for the page reports, we need one big table, right? But for Power BI, we need the star schema. So it's not about if you believe me if I tell you that it's important to do this, because it is a matter of fact that Power BI is optimized for the star schema. So it's optimized for one-to-one many relationship. It's optimized for one-directed filters, right? Where there's only one triangle between in the filter relationships. That means you should avoid many-to-many relationships. You should avoid detached tables. You should avoid key pair model, key value pair models. And this is exactly what I will show you. So, but I just want to warn you, right? A word of warning: don't use this talk as an excuse to then always model things in a many-to-many fashion, or don't not making relationships between tables at all, because we can have detached tables, right? We can have relationships in DAX. So this is only more or less advanced extreme use cases where it's good that we have these features, but it should not be in your bread and butter, bread and butter data model. The agenda is I will talk about multi-fact models. It means that we have more than one fact table. This is still a star schema. We could like say it's like a universe or the galaxy, because it's 2 stars, right, or 3 stars. We will talk about the many relationships which we need there. I will talk about the detached table, what I solve with this, and I will show you whatever I can in this 50 minutes or 40 minutes I have left for the key value pair model. The multi-fact models. That's a model having more than one fact table. And why would you do that, right? Because you should always try to move everything in all the information into one single fact table. It doesn't make sense to have several fact tables. They're only necessary if the granularity is different. So for example, think about you have your actual values and you have a budget. Usually the budget has a different granularity. The budget is not like on, doesn't have timestamps, right? You do the budget per month maybe, or per half year or quarter. Maybe the budget is not on product level, but on product category level or product group level, things like this. The granularity is different. And this means that you should model this in a separate table into two different fact tables. Why would you, and you should only put it into one single dimension, in one single model if there's at least one dimension which are in common, right? If it's two different models which have nothing in common, then it doesn't make sense to put it in one data model. Make two different Power Pivot or Power BI desktop files out of that. So only if there's at least something in common and the perspective dimensions, then you should model it in one thing. And still, it says here, it will become very common with the GA of direct query mode over Power BI and analysis services. Luckily enough, this is already in GA, and luckily enough, they changed the name, right? This was an awful name, direct query mode over Power BI and analysis services. This is what we now call direct query over a Power BI dataset. And this is available, so you can connect to two different Power BI datasets, for example, within one Power BI report, and then you have, like in this Power BI report, you use two different models instead of your two different fact tables, at least two different fact tables. So this is a very common scenario which can happen, especially in self-service environments. As a use case for this, for the demo, I used budget. As I already told you, that this is very typical that the budgets and the granularity than the actual values. And then we will talk about different solutions like Detached. So this is pronounced Detached. As you can hear, English is my second language. So when I first saw this function name, I thought it's a Greek goddess. I thought it's Triates or something, but no, it's Detached. So we're treating something as there would be a filter applied. We will see the many-to-many relationship in this demonstration, and I will also use the bridge table. Let's jump into my machine, demo machine. Where is it? It's hiding here. So what I've got here is I've got a simple model, right? The model is very, very simple. So what I have here is I have my actual values. That's a sales table. There's a sales table in here. And I have a budget table. Both are on the many sides, right? So this is my fact tables. And then I have two-dimensional tables, the date and the product. Just for the sake of simplicity, I also already have a relationship between the date and the budget because I also made the budget on the daily level. So there's something in common. So I take one complication out of the equation, right? But between the product and the budget, I didn't create any relationship because the budget is on the product group level, and the key here, the primary key, so to speak, is the product ID, not the product group. So if I would create this relationship, I get this warning. Right, so it's a warning. I can still press OK, so I can ignore this if I want, and it's telling me, oh, and I have to excuse. I obviously started. I did a training the day before yesterday in German language, and yesterday it also happened to me. So I will change this in a second. It's warning me that this relationship has a cardinality of many to many, and you should only model this if this is expected. It's not really expected because it's not a many to many relationship. It's just like, I mean, it's not a matter that one budget can have several products. No, it's just one product group, right? And one product group, yeah, can have several budgets, but yeah, does not really make sense in my opinion to model this as a many-to-many relationship. So I will cancel this here. And just by the way, to make sure that when I open the next demonstration file, I will have everything in English. It's easier for you to understand. So it's the regional settings, and then I want the Windows standard thing here. So yeah, for this first demonstration, will stick in English, in German. So, and after sales table, I had the product table here and the budget table here. And just to make it easy to understand, I have shown those tables, the relationships, and I did show that there's no relationship here. So what means this for our report? So I have a report here with the month, the group, and then the sales amount. And we get 33,000 for the sales amount for group 1, and in February 2023, right? So everything is from February 23. So basically this is the number here means for group 1 consists of product A and B. So that's 100 and 110. The first 3 rows, they are from group 1. That means 3 plus 20 plus 10. This is 33,000. And the 15,000 is then what we have from group 2. So group 2 consists of products IDs 120 and 30. There's only a sale of 120. So the 15,000 here is this. And the sum of those two values is the 48,000. Everything fine for the actual values. But for the budget, it looks a little bit weird, right? We get the same number twice. I mean, this could be, right? In theory, why there's nothing which forbids me to have the same budget for two different groups. But what's really weird is that we, as a sum, we don't see the sum of the 27 here, right? It's 60,000 instead of, it should be like 54,000, what I would expect here. So what's the problem here? Obviously, it's because there's a relationship missing. But how are the numbers calculated by DAX and Power BI? So what it's doing is that there is a filter between the date and my budget, right? But there's no filter between the group and my budget. This means in this line here, I have a filter context for the February and group 1. The filter for group 1 is totally ignored, but the filter for the date for the February is kept. So it's looking up the budget table and looking up for my budgets, which are for February. And the first two lines are for February, as we can see here. The others are for March. The group thing is totally ignored. That means it's summing up those two lines, which are both from February, because the group is not filtering at all. And 20 plus 7 is the 27 here. For the next line, we have again February. It's a different group, but the group does not really filter the budget table. It's only filtered by February. So we are here again, because again, it's the two lines here. 20 plus 7 is the 27 we're seeing here. And then there's a huge discussion sometimes on the internet, right? Especially one person complaining since like many days and years that Power BI is so dumb and silly and cannot really calculate numbers here. But the thing is that it's calculating by default. It's never calculated as a sum, and it's a good thing because this is what you need sometimes. And here it's showing that there's an issue, right? So I'm glad it's not just summing up the numbers here. So what are the 60,000 here? You should remember that when the total is calculated, by default, it's not calculating this as a sum. By default, it's calculating this in a different filter context. So it means here we have a filter context with a month and the group selected. You have the same month and the different group. And here in the total, there's no filter. So because I didn't have any other filter, so there's no filter at all. This means, it's just summing up everything from the budget table. And the 20 plus the 7 plus the 25 plus the 8, this is the 60,000 we're seeing here. So now we set the scene, right? So now we know the problem. What's the problem? How can we solve this? And there's three different ideas I want to show you. So one is we can have a calculation arm. We can have a relationship. We can build a relationship in DAX. So I don't change anything in the model, but I use DAX for this. And before we talk about the DAX statement here, let's take a look how this looks like. So this budget readers is the new version of this. And budget readers shows now for February in group 2 shows 20,000. And this is right? Group 2 in February has 20,000. But February, for March in group 2, it shows 25,000, which is the 25,000. And the sum is 45,000, which is, yeah, discussable, right? It's like the right number if I see these two numbers. But in fact, it's not the total because the total will be still 60,000. For some reason, the group 3 is not showing up, right? So we still have a problem with this tree there. So it's solving a portion of the problem, but it's not solving all of the problem because there's no group 3 in my product table. And what I'm using here is the product table. So we need to find a solution here. How is this done? This is done by the calculate. So a good friend calculate, a very, very powerful function in Power BI. So calculate is very powerful, and I underestimated it because I thought that calculate. I mean, what should this function do? Of course, I want to calculate something. That's the main goal when I'm writing a DAX measure. I want to calculate something. So why would I wrap something in the calculate into the calculate function? But first of all, I'm passing in an expression like sum of the budget. But then I tell it, please change the filter context. So manipulate the filter context. In the current filter context, it would, for example, mean that there's a group 1 here, but this group 1 is not filtering the budget. So I ask for, please come up with a list of values for my product tables product group. So in this line, the first line here, it would be group 1. And then apply this list with 3 days on the second parameter, which is the product group. So I'm taking literally the available product group or product groups in the product table. Then for the second line, it's applying group 2, right? There's something on group 2. And of course, also the date is filtered in the budget table. That's why we see the correct 20. So this is like sort of working, but not totally. So what if I would then use this many-to-many relationship? So maybe I saw 3 that solves a bit of the problem, but not the full problem. So maybe I'm brave and I accept, yes, this is a many-to-many relationship. It's not really many-to-many relationship, but I'm using it here. So I press OK here. So we get this weird thing here. So it's telling me, be careful, because this is like a weak relationship. It's not only many-to-many, but also weak. So if, for example, if I remove filters in DAX from one of the tables, this will not be applied to the other table. So that's some extra things you have to take care of this. For the direction we can discuss, because I only want from the product table to the budget table. So there's no need to have it both, but I change it from product to the budget table and apply this filter. And jump back to the report. So what's not now happening is for the budget column, we also get the same numbers and we still get the 60,000 here. So maybe it's better, maybe not. This depends on you. But both have the backdraft that the group 3 is not appearing, right? So let's close this down. I do not want to save this. And I show you the other one where I build what I believe is the better solution. And as you can see from the file name here, I call this bridge, because this is a modeling approach as Teams and Power BI competing over the resources. So with this version, I have the budget here, I have the actual values here. So the actual value, the right one, I hope. This is over 48,000 here, so something is weird here, if you ask me. Not sure why this happened. Let's consider on the budget first. So I've now get the 20,000 for the group 2 and February. This is the 20,000. I get the 7,000, which I did not get with the other solution for group 3, right? This is the number here, and also the other 2 numbers. And of course, this makes sense to sum it up to 60,000 because that's what the budget is here. So how did I model this? I modeled this with a bridge table. This means I have my budget table, I have my product table, and still this is a many-to-many relationship between the budget and the product table. You can see that both tables are on the many side, but in between I squeezed in the bridge table. What's the bridge table? The bridge table is a simple, distinct list of my product group values. So if we enlarge this here, so what I'm asking for, please give me a distinct list of the product group of the budget table. Please give me a distinct list of the product group of the product table, union them. So just put one list underneath the other. And then again, there could be product groups like the product group 2, which appears in both in the budget and product. So there could be duplicates. That's why I again apply the distinct here. And I think the best is to show this in the zoom it is not starting here. Where's my zoom it? Does it work? Yes. So zoom it, then we can see like the group here. And we can even see like how to build the list, right? Because from the budget we get the product group 2 and 3, and as we have this distinct up there again from the product table, it only takes the group 1 here. So this is how we can build this. And this solves most of the issues. So instead of having 3 days, which can be slow, and many-to-many, which depends on if it's slow or fast, but has other backdrafts, I usually model things with this bridge table in between, because this is how I learned this 30 years ago when I learned about data modeling in databases, in application databases. So 3 days, like, builds up a virtual relationship. So it's not that your active relationships are like envy, but there is a trade-off. There can be a penalty in terms of it can be slow, because if you build a relationship in a data model, it means that like sort of an index is built inside of your data model. So Power BI or DAX can very fast find the connection between the 2 tables. If you don't have this relationship, then this index is not there, and therefore things might be slower. I implemented this for one of my projects where one of the dimension tables had over 1 million rows, and we had to use 3ds because there were no other way around, and it still was a good performance. But please keep this in mind. Yeah. Okay, next approach is a detached table. So instead of yeah, we almost have seen this, right? Because we have seen that there was no connection between the product table and the budget table, and I created something with 3ds. And this is very useful in some ways when there is no way of having a physical relationship in the model view. And this is in situations where you have a complex relationship. And the complex relationship means that if you build something in the data model in Power BI, it always has to be an equijoin. That's the technical term here, equijoin. It means that you connect two columns, like the product key in one table and the product key in the other table, and the product key has to match. There has to be equal. That's an equijoin. We join things on the equality. But there's situations where we want to join on like something is greater equal something or lower equal something else. So this is a more complex relationship, and Power BI does not allow you to model something like this in the model view. And this is what we can then reach out to DAX. So that's the use case for the next demonstration, which is binning. So binning means that there's several approaches, and one we can use like building a table which describes like the low values are these values which are lower than 3, and the medium values are between 3 and 5, and everything bigger than 5 is then a big number, right? This would be idea here. So instead of showing the actual value in the report, I want to show a bin, like a description if a value is low, medium, or high. And this is what we directly jump into the demonstration again. So one approach where we don't need DAX, but what we can model in Power BI, which I think is a very, very interesting approach also, is like, let's see our example. So I have a very simple table here, as you can see, four rows in the sales table. That's not bigger. I have different quantities, and I want to show if a quantity for a product was sold as a low, medium, or high quantity. And the definition is here. So if the quantity is 1 or 2, it's low, 3 or 4 is middle, 5 and 6 is high. So product A is showing up here with 1 sale. That's right. We sold it just once. The quantity was 3, and 3, according to this definition table here, is middle. That's why it's showing up here. The product B we sold 2 times, as we can see here, and 1 with a quantity of 1, which is low. This is here, and 1 with a quantity of 4, which is the middle. And product C was sold once with a quantity of 5, which should be high, and it is here. So this is what's the goal, right? And what you should not do is that you enrich your sales table and adding this information low, middle, high there. The reason is this because fact tables tend to be the huge tables, and if I add columns there, it means it takes extra, it can take a lot of space, right? Because if I add 1 byte of data and I have 1 million rows, that right? And it can be like if it's 2 bytes and it's a billion rows, then we talk about 2 gigabytes. And that's what we do not want on the first place. And the second thing is, if you add this information to a sales table, and sometimes somebody asks me, now there's inflation, right? A value of 10 is not like low anymore. 15 is low, right? But 10 is not medium anymore, but this is low now. Then you would have to update the whole sales table and to refresh everything there. With this approach, I keep this separated. If I update something, I only update these 6 rows, which is very, very fast. And during query time, I then assign things there. And the first approach is not a detached table. The first approach is an approach where I have my bin table, we just have seen, and my sales table. And this is also a little bit unusual, I would say, because we're joining those 2 tables not on the key, on the product key or whatever. We're joining the table on a measure, right? There's a quantity in my sales table, and I join this with the quantity in my bin lookup table. This is very fast, as we can think of. The backdraft is we have to come up with a list of all the possible values, and somebody has to maintain them, and somebody and whoever maintains them has to be careful to not make any mistakes. So not 4 is high and 5 is middle, for example. This would be confusing to people, right? So that's the only backdraft here. But maybe that's not flexible enough because sometimes there can be endless values in between, right? If you're talking about decimal numbers, then it's really hard to come up with a full list of all those decimal numbers. So what's more smart, before we take a look on this duck statement, let's take a look here. I have this bin range table, how I called it, which tells me that low values are lower than 3, so this is exclusive, greater or equal than 3, but lower than 5, or if it's greater or equal than 5, it's then in the high value, right? And those, like the edge cases, I just let empty because I don't care how low the value could be. It could be minus, right? I don't care. If it's below 3, then it's low. And the result is the very same. So what's happening here? First thing is that I have the sum x here, which is not really necessary. This could also be a count rows, right? What I'm using here is a sum x over a complicated filter expression and then summing up the value of 1. Every time I show this, I just can't remember why I used the sum x. I mean, I know why I used the sum x here, but I'm not sure why I didn't change it to count rows here first to make the explanations easier. Because sum x with 1 is just counting the rows, also replace it by count rows. I think that when I prepared this example, I took it from one of my real use cases, and for this real use cases, we found out that the count rows was slower than the sum x over 1. This is some of the surprises Dux brings sometimes with it. So sometimes a sum x with 1 is faster than the count rows. That's why I'm using the sum x here. And I have a filter and another filter. So there's 2 filters, and one filter is iterating over the sales table, and the other filter is filtering over the bin range table. So every row in my sales table, I'm iterating the bin range table. So if I, for example, at the first row here, right, with a quantity of 3, then I look up the second filter. It looks up if the quantity is not blank. If it's blank, then it's just ignored. But if it's not blank, we're looking up if the quantity is greater or equal than the lower thing. 3 is lower, is greater or equal than 3. So the middle, this would be fine. This would not survive. This would also not survive. And we're also checking if the quantity 3 is lower than the high, lower than 5. So this would be assigned to middle. Then for the next row, 1, it's again, it's not blank. It's looking up for quantity greater or equal than the lower value. It's not really passing. It's not lower equal. It's not greater or equal than 3. It's not greater, greater or equal than 5. But this is why I have this is blank here. So maybe it's not greater or equal to any of the values, but if the low value is blank, then it also could be fine, at least if it's also fulfilling the other condition, right? So we are still at 1. So we're checking that the 1 is lower than 3. So this row would survive. 1 is also lower than 5, but it didn't survive the first condition, and also the other one not. So that's why 1 is assigned to the value of low. That is what I then return. So if it can find something, if this bin thing, this filter is not empty, I'm returning something. So this row survives, and then some x counts these rows. So this is how you can implement things with a detached table, having more complicated relationships. Again, there could be a penalty. Applying these filters without having this physical relationship might make things slower. So depending on how many rows you have in a fact table, how complicated this bin range table is, the performance might be better or worse. The key value pair model. What is this? This is, in theory, that's a table with only 2 columns. That's why it's called a key value pair model, because this table only has 2 columns. One column, a key, like this is a text, right? It says name, or it says birthday, or it says salary, and another column which contains the value. So for the row where the key says name, maybe the value is Markus. And for the birthday, it's then my birthday, and so on and so forth. So this is very flexible, a very flexible approach. Practically, there's more information available in this table. So for example, there should be an ID because we want to keep many people in there, right? I want to distinguish the name and the birthday and the salary from one person from the other person, right? So maybe there's also an ID there, some sort of key. So there's a row for Markus and there's a row for Jeff. There are rows, there's not one, there's several rows for Jeff, and there's several rows for Markus, for example. And hopefully, as we will see, this would be very, very convenient if we would have this. There's in many of the key value pair models I had to use, there's a type descriptor variable. So it tells me that like for the key of name, that the result is a string. And for the birthday, the content of the value is, of course, it's a string, right? The data type of the value column is of data type string, a character, but the descriptor tells me it is a date, maybe in a special format. So this would be very helpful. This is very common in some of the applications because for application developers, this is very, very flexible. So if somebody asks them, please, can you add another attribute on this formula, on this form and store it in the database? They say, yes, of course I can. And then they just add another row in this table. They do not have to change this. Sometimes I have the feeling that regular developers, they are scared from database schema changes because they're complicated from the point of view of developers. But it's extremely hard for people to build reports on it, as you can imagine, because we have to pivot the result, as I will show in a second. So jumping to my key value pair table. So that's a key value pair table here. So what I call here is this ID column, right? It collects the first, the second rows, and the third block here. And you have a city, for example, first purchase, a name, revenue, and zip. And these keys might be replicated within the other ID or not. They're totally flexible. So there can be some attributes are maybe only available for some of the IDs and not for the others. But building a report like this would be annoying, right? So everybody would tell you, Bill, please make me a good report out of that. What's really cool with the key value pair table, so sometimes I intentionally introduce this sort of concept in a data model, is because we can have very flexible reports. Like for example here, I show now on the rows, I show the name, as we can see here, the name is selected. On the columns, I show the city, right? And then I count values. So I see, okay, there's one Bill available who lives in Seattle, another Jeff also in Seattle, and Markus lives in Nakoven, obviously. We have two people in Seattle. We have one person by name each, and in total we have 3 people there. And then the user can just change things. So instead of the city, I can also just show the zip, for example, and change it to zip name. Or I could like show the first purchase instead. So very, very flexible. Navigating table when I'm up for like what is it called? It's I'm not missing the English word for that. So I can see like if there's relations, like if there's something special between these attributes and the other ones, if there's like groups there, this can be very insightful. For example, I did a project for an insurance company, and they can see is there like something special between like the zip codes and if somebody smokes or not, or if there's something like male, female, diverse, and certain diseases, for example. This is very easy to find out with a model like this. But for usual reports, this is not very useful. What we can do in Power BI is I can put everything here on a matrix, like matrix visual, and then ask them, please put the ID on the rows, put the keys in the columns, and then the values here in the value section. It's like easy to remember. It says here first value because it can only show one value, right? In my table, nothing prohibits me from having, like for ID 1, 2 entries with 2 different cities. So this cannot be prohibited in the table design of a key value pair table. That's why we have to provide something either first or last, only counting things. So if I want to show something, I have to specify in the case there would be more than one value available, which one of those values to show. That's the one weird thing. And the other weird thing is that if you take a look here on the revenue, it's like left aligned. And if I sort things for this column, can I do this? For some reason I cannot sort it. Sort by first value. Because this is a string, right? This is not a number, which is really weird, especially if I try to turn on, for example, my row subtotals, right? So if I do this, then we get this weird thing that also for the city we get a total, which doesn't really make sense, right? And for the revenue, it's really, really weird. It's telling me 19,000 is the sum of those 3 values. Of course, it's not the sum, right? I just did show you that we told the system that it only should show the first value. And again, why is 19,000 the first value? 5 should be the lowest value, right? So why it's 19,000? Because it's a string. It's ordered alphabetically, and 1 on top of the on first letter of the string is before 2 and 5. So this is like the smallest string, so to speak, in the revenue is the 19,000. So this is, as you can see, this doesn't really make sense. We cannot build reports in this way. Everybody will be confused. Everybody will complain about it. So we have to implement something more smart. And there's several things we can do. We can solve things in DAX. We can solve things in Power Query. I think for this audience, I will stick with Power BI, right? And I think that the better solution is the Power Query solution over the DAX solution. So if there's time at the end, I also will show the DAX solution. But unless I'm running out of time, then I will only show the Power Query solution. So let's go to Power Query. And of course, this is opening up on the wrong screen. Let's move it here. So what I'm having here is I have my source table, right? The source table is exactly the table we just have seen, which is the ID, the key, the value, that's where the name comes from, and there's this type column, which tells me what the type of the revenue, for example, is. It should be, and this could be anything, right? What I did here, I chose the names of Power Query data types, but this could be anything. Like in the project I already mentioned, I think it was 1 was a date, and 2 was a string, and 3 was a number. It could be anything, right? We can react to these data types as we need and as we want. And to solve this in Power BI, we can pivot the thing. So what I do here is, I think for the demo, I take a copy of this, the source, I reference this, and then I click on the key thing and tell it, please transform this and pivot the whole thing. I think I can also click pivot here. Pivot, no, I want to pivot things. It's here, pivot column. And when I do so, I can say, no, the value column is not the ID, but it's the value. And then I press OK. And before I can do this, I have to remove the type. So I remove the type here because I do not want to have it be part of the pivoted result. And then again, I come in here, pivot, and tell it that the value column is the values column. And everything is pivoted. As you can see here, there's still a mistake because we get 1, 1, 1 here. So what's the problem here is that we need to look for the advanced options. And by default, so it's telling me how many rows were there for ID1. So how many names were there for ID1? Now, this could be nice in some situations, but it's not what I want here. Again, I choose the minimum function here. So we should end up with Bill, Jeff, Marcus, and they have everything in different columns. So far, so good. The next step, what we need to do is that we have to assign the right data types. As the value column is of data type text, because that's the common thing for all the data types, everything can fit into a text. Everything is a text here, but I need, for example, the first purchase, this should be a date, right? So I have to change this to a date. And for the revenue, here it is, we need to change this to a whole number or decimal number or whatever. And this is what I don't like, right? Because the reason in first place why there's a key value pair table is that obviously the source system can always add other attributes, other keys. So every time they change something, I have to go to Power Query, look up for the new columns and assign the right data types there. This is something I don't like, because if the data changes, the code should not change, right? But the code in Power Query needs to change in order to apply the correct data type. So I thought about, is there a better way? And yes, there is a better way. So what I built is here. So for this final dynamic, as you can see here, this is just like a source. I use a function here, where I put in what are the names of my columns in my table, and it will automatically react to whatever I have in the source. So if I have, for example, I add something here in my source, I used here this great table feature, yeah, because for demos it's really, really cool. And for example, if we add another int type, whatever, let's have, what do we have here? The revenue. Let's add the salary, and let's assign, I don't know, 4,000 for the first ID here. So we get this row here. If I jump back to my final dynamic solution, and if I look up for the salary, it's automatically detected as an integer. So this is really cool because this gives some flexibility, right? It's automatically reacting to things. So how did I build this? There's different things I had to build up here. So one is that I came up with a table in Power Query telling the system if the source type in my key value pair table is text, it should be converted to the type text in Power Query. So this is like the reference thing here. In case the source type is not delivered or the source type cannot be found, I invented something to try out different data types. So it still will find an appropriate data type, but this will not be perfect. I will first try out if it can be converted to a date time. And if I can, then I tell this is a date time. I cannot check if there's like, it's hard to check, right? If it's really necessarily a date time or a date will fit also, right? So this is what the solution will not then detect for the thing. So the function is this one. So if we take a look to this Power Query M code, and always if I stuck something and I'm stuck in Power Query and I look up the interwebs for a solution, I always come to Imke Feldman's post. So if you do anything in Power Query, please make sure to bookmark the BI accountant because she has brilliant solutions there. I think she natively writes down M code, which I cannot. So I took great portions of that. I think I changed a little bit of to change it more, make it more flexible for the column names, but the whole idea is from Imke, it's not from me. And what we're doing, what she is doing here is that for the key column, it's just looking up per key column what kind of type it can find, and somewhere there should be the transform columns, and then it's changed the types from one type to the other type, right? So this is basically what's happening in here. What I squeezed in is that I tried to, where is this, where I tried the different data types? It's not in here. It has been a while. Yeah, type from any. This is what I wrote. I think this is my code res. So I went through the thing. So I get whatever I get, right? And then I try if I can convert something into logical, because this would be like the least common data type, right? If it can be converted into logical, then I, of course, it's for sure logical, right? If this fails, I try if I can convert it to a date time, and then I assign the date time. If this also fails, I try if I can convert it to a number and then make it a currency, which is like the fixed decimal number. And if all three fail, I say, okay, obviously it's a text, right? So this is failover in cases where the data type is not delivered with the key value pair table, and or the key value table, it's a new data type and it's still not in my lookup table. Makes sense? So there's more advanced stuff here. And then I can, I've then, the result of this is then a wide table, like one big table. And of course, then the data modeling starts from here, right? Because now we have to find out what's the effect table, the effect part. What should I make a dimension table out of that? So this is only the first step to tame the key value pair tables. Okay,
Hi, Markus, I have a question myself about this.
Yeah.
I don't know if you could maybe go back to the fundamentals of the key value pair and when you would decide, I think you may have gotten into this in the beginning, but when you would decide to use that method versus maybe adding a table that contains a certain type of value.
I'm not sure if I understood the question. What do you want me to go back?
I guess, when would you make the decision to start using this key value pair table?
Okay. The thing is that, like in Power BI or in BI, right, we cannot decide how the source system is designed. So we are just victims of decisions of people previous in the data chain, right? For the developers, it makes sense to have this key value pair table because sometimes they are afraid of creating a real table, because if they create a real table, they have to think about the data types, right? And every time the UI changes, so they have a new field on the form, for example, then they have to change the schema in the table to make space for the new attribute. So that's what I see, that sometimes developers enjoy the flexibility of this key value pair table. On the cost, of course, of me when I try to make sense and build reports on that. Does it make sense, Steve?
Yeah, that's very helpful. So I think I really like it. I actually think I remember something like this. Going way back to Oracle days, but I haven't seen it in such a long time, and it's very intriguing because it gives you a lot of flexibility, as you said, without changing the schema.
Exactly. Yeah. For those people who write in the table, that's easy for them. But everybody who needs to read and report on the table, it takes a lot of burden on them. Or I mean, not now, because as you can see, I can share the whole content of this, so you can also use this function, and then you just apply this function, right? And you get this dynamic approach, and don't have to think about anything here with the key value pair table.
Yeah, that's great.
And all the complications. Okay, other questions, because I think I'm at the end of time, or end of my time. Yeah, the description what I did here. The takeaways out of that is take care of your data model before you jump forward to these advanced things I did show with many-to-many and treat as and non-related tables and bidirectional filters and other complexities. Please make your homework first, make it a start schema, and then on top of that, it makes sense maybe to reach out to more complex features. So the idea of these complex features is not for the bread and butter data models, but for certain use cases which cannot be solved otherwise. And then I'm really happy to have bidirectional filters available, for example. Okay, there's also links out there. And any questions?
No questions in the chat at the moment. So thank you so much.
Thank you so much for having me, and enjoy the rest of 3-4 hours. Now, when you're done, in 3 hours, I think, right?
Yeah, we're getting there.
Yeah, very good, very good. I'm crossing my fingers, yeah, for you.
All right. Thank you so much, Marcus. I enjoyed that. I like learning about Power Query and Power BI, so that was great. For all the attendees, I've put on our slide to ask you to provide feedback. We do really appreciate hearing what we've done well and where we can improve. So we'd love it if you would send feedback.